All right, so we're going to go over one of the problems for your homework today. First of all, I noticed that in Kami it did not show up the drawings that I have here. So first of all, you need to draw these drawings. So take out the worksheet on Kami. If you didn't print it out, you can draw these out on a piece of paper because you'll have to redraw them in Kami. So you have a beaker, and then attached you see this metal portion right here. This is labeled as magnesium, and then you have Pb on this end. The solution that you see is magnesium nitrate, see Mg2+, in the ions. Remember, in the solution it's the ions. You have a connection, just like in the video, and then you have something called the salt bridge, because they are ions, so it's called the salt bridge. And in class we would have just used some sort of cotton. We're going to go over this example all together. Let me erase that side here. All right, so it says write the possible reduction half reactions. You can get these directly from your sheets. So I'm going to write these down. Apologize in advance. Am I writing here? Trying to ink that. Plus your 2 electrons, again from your sheet that you have, yields magnesium solid. I'm just going to note the voltage right here because I know I'm going to need that later. Because ultimately, this is a battery. You're trying to figure out how much voltage is given off from this. And then you have your second reduction half reaction, Pb2 plus 2 electrons, and then it yields this solid. Again, I'm going to write down the voltage that I had on the sheet. It says select from A the half reaction that is most easily reduced. Okay, the one that's most easily reduced is the one that gains the electron. So that's my explanation. So I'm going to look at the 2 according to the chart. Pb2 plus is easier to reduce. And my explanation will be really brief. It's just it gains electrons easier. And you know that because you're comparing the 2 off of that given sheet. And then it says select from A the half reaction that is tougher. And if it's tougher to reduce, that means it's easier to oxidize. So that'll be the other, Mg. Okay. And then I'll just say easier to oxidize. You're losing electrons easier. It says then part D. Let me move the slide down here a little bit. Okay, I'm going to try to squeeze that all in. Reverse the appropriate half reaction from part A such that now you have the GER portion half reaction and 1 Leo half reaction. So you're going to have a complete redox reaction. So I'm going to bring this, I'll write it over here, that's a good idea. I've got my inking pen here. So my magnesium was easier to, it originally looked like this. I'm going to write that down just so you can see it from above. And because it is easier to oxidize, I'll flip it. And it will look like this. And because I flipped it, I'm also going to flip the voltage. Keep that in mind. I'll separate that voltage from the rest of the information. And then I'm going to keep my Pb. So my Pb solid. I'll just shorthand it over here and I'll redraw it. So I have Pb2 plus 2 electrons yields Pb solid. So now I can combine them to make an entire redox reactions. And this is what we practice with the other day in the other day's assignment. Because there's 2 electrons on either side, I didn't need to balance it at all, so I can just cancel those out. They're on either side of the arrow, and I will bring down the items that I have from both half reactions. So Pb2 plus my magnesium solid yields, and again, it doesn't matter which one I write first on the product side, as long as they're both on the product side, or the reactants on the reactant side. And I didn't keep with this information. I'll rewrite that up here. So it then asks you, determine your actual conductivity of that E cell. So the E cell, you can add the information up and you get positive 0.24 voltage. So that's that information right here. So because it's positive, it is considered a spontaneous reaction. Then it says write the shorthand. Well, the shorthand's kind of nice. I'm going to show you really quick how to do that. You're just focusing on the actual elements at play. So here the shorthand would be, I have magnesium, and it's going to, so one line, to magnesium 2 plus. So that way I can focus. Is that being oxidized or reduced? In this case, it is oxidized because it went from a 0 to a +2 charge. Okay. And then I make a double line, and then I have Pb 2 plus, and it's going to, so look at that, going to is just a slash Pb. So this one you went oxidation state 2 plus to a 0 if I were to draw that there, but I won't put that in the answer. Let me erase that. So that one was being reduced. So in a shorthand, you can look at this and immediately, tell if something's being oxidized, which is magnesium, and which one's being reduced. All right, let's go down a little bit further. Can I go down? All right, I'm gonna just show you what the questions are, even though you have that in front of you. Add to the diagram, add to the diagram, add to the diagram, label, 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 and describe what's happening in each of the beakers to the electrodes. Again, from the videos that you watched, you should already know what's happening. And if you haven't watched the videos, make sure you go back to watch those videos from the lab. All right, so I'm going to erase just, oh my, I think I just erased part of what I didn't want to erase. So let me get that back up. That was what I inked earlier. I apologize. Let me get this back in. My metal and my liquid. There we go. And then I'm back in the red ink. Okay, so the first thing says add to the diagram the direction of electron flow, and then add to the diagram the movements of the ions, add to the diagram the movements of the ions in the salt bridge, and label the anode and cathode, label the positive and negative electrode, and then describe what happens. So I'm going to go through and actually label everything. So your flow of electrons, first of all, your anode and cathode. Your anode portion is the negative portion, so that is your anode. And this is the side that's being oxidized. So the side that's being oxidized is considered your anode, and your reduction, I'm going to label that reduction. That would be considered the cathode portion. The way to remember it is the same way we did in the beginning of the year. An is a negative, cathode is positive. There's a little T in the word, so that kind of helps you remember what it is. Let me keep going. Looks like my computer's giving me a little bit of glitch. And then it also asks you the flow of electrons. Well, the flow goes from the anode to the cathode. So I'm going to show the flow with the arrows like that. I'll put some arrows here to show you. So your electrons are flowing from the anode to the cathode, anode to cathode. And that's the flow of the electrons. And what's happening is that you're actually, I'm going to make like a little jaws chomp. This is being removed. So little by little, you're removing part of this metal in the anode portion, and it's adding to the cathode. I mean, that's actually what's occurring through this process. So you're just going to be going through, and this is how I'm showing that it's being removed. It's going to be removed here. It's going to keep being removed until there's no longer a flow. Well, you'll notice that I didn't actually show a flow. I just showed a one-way direction, but a flow should go all the way through. So here we have your salt bridge. So we've got ions, and I'm going to show what's happening to the salt bridge ions. It's going, the positive's going to this area, and the negative's going to the positive here. So the ions are flowing in this section to maintain that neutral charge. Okay, so this is what's happening in that salt bridge. So we can keep going, the ions will keep flowing through. Flow through, flow through, flow through. So that salt bridge is making a connection between the two beakers, which is one's the oxidized and one's the reduced. All right, so hopefully this will help you. I do want to go through, you can obviously pause, go through, go back and forth with this. Let me go through what the video is going to, I mean, what I'm going to show you right here. You need to draw this next image because it did not come up in your actual Cami. So you do need to draw this down. Let me see this. Pen it. This is what you need to draw down. So you're going to be practicing the same exact thing. It's going to go through the same exact steps, and then you're going to be able to complete that. Then you have one final one, and you'll notice in the final one that I gave you, I didn't actually draw it. I want you to draw it. I want you to show me the piece of metal, show me what's in the solution, show me the movement of the ions, or the electrons rather, and you're only given the shorthand of nickel and gold. Okay, so nickel and gold. So what's happening ultimately to the mass of gold piece and what's happening to the mass of nickel. So this lab isn't usually run because gold pieces are super expensive, but in theory this would actually be able to occur. So you are going to then solve for that last one. So hopefully you have this down, and if you have questions, go back and review the video.